If the object is at rest, V equals 0. Therefore, A equals 0. Sum of the F's equal ma. Therefore, the net force must be equal to m times 0, which would make sum of the F's 0. Similarly for B, if it's moving at a constant velocity, then that means A is 0. It is not accelerating. And then we have the same situation as in A. Okay? So you have sum of the F's equal 0. For this one, you need to think in terms of inertia. So, as a friend, you should refuse, because if the truck makes a sudden turn, the piano will try to maintain its state of motion in that particular direction, which will be in a different direction compared to the truck. This will result in a very heavy piano moving uncontrollably in a closed space near you. Very dangerous. So A is the racket is in contact with the birdie. Therefore, if that is the birdie, we're going to have our FG going that way, but we're going to have also an F applied going that way, making the birdie go up. For B, the birdie is rising in the air, so we have no longer any applied force. We still have our same FG, but now we also have air resistance. Now air resistance is going to oppose motion, so we're going to draw it like that. Force of air resistance. See, the birdie is stopped, so it's at the top of its flight. So if I were to draw it over here, we'd be looking at that point right there. So in that case, V is going to equal to 0. If V is 0, there is no air resistance. Therefore, our free body diagram simply looks like this. Just FG. D says the birdie is beginning to fall, so air resistance exists, but has not reached its maximum value. So it's a little different again. So there's our FG. Now the birdie is falling, so it's going in a downward direction. Air resistance is going to oppose motion, so therefore air resistance would go up. Force, air, resistance. For these questions, we're going to use the formula F equals ma. Now we're always looking for acceleration, so therefore our formula is going to rearrange to A is going to equal to F over m. For question A, and don't forget that's sum of the forces. Sum of the forces is going to equal to 27 newtons west. The mass is 63 kilograms, therefore A equals 27 over 63, which is 0.43 meters per second squared west. B, sum of the F's is 18 newtons forward. The mass is 7.5 kilograms, and therefore A is going to equal to 18 divided by 7.5, which is 2.4 meters per second squared forward. C, sum of our F's is 32 newtons up. Mass is 95 grams. Now 95 grams is going to equal to 0.095 kilograms. Remember, any kind of force calculations needs to be in kilograms. So therefore A is going to equal to 32 divided by 0.095, which is 3.4 times 10 to the 2 meters per second squared up. Like the previous question, we're going to use the equation F equals ma, except now we're looking for the magnitude and direction of the force. So we're going to keep the equation as is. So in A, mass equals 5.0 kilograms. Acceleration, we are told, is 5.0 times 10 to the 3 meters per second squared. F equals ma. Therefore, 5.0 times 5.0 times 10 to the 3 gives us 2.5 times 10 to the 4 newtons forward. Okay. There's our magnitude, and there's our direction. B, very similar. Mass is 28 grams. 28 grams is 0.028 kilograms. Acceleration is 2.5 times 10 to the 3 meters per second squared east. Therefore, F equals ma, which is 0.028 times 2.5 times 10 to the 3, which is equal to 7.0 times 10 newtons east. C, mass is 1.6 times 10 to the 5 kilograms. Acceleration is 1.2 meters per second squared south. F equals ma, which equals 1.6 times 10 to the 5 times 1.2, which is equal to 1.9 times 10 to the 5 newtons south. For question 7, we are asked for the mass. So we're going to use our same equation, F equals ma. So we're going to keep using Newton's second law, but we're going to rearrange to find mass. Mass is going to equal to force divided by acceleration. Now we are told, I'll do it over here. We are told that F, sum of the forces, equals to 7.2 times 10 to the 2 newtons forward. We are told that the acceleration is 1.8 times 10 to the 2 meters per second squared forward. So to find the mass of the shot put, we take the force, 7.2 times 10 to the 2, divided by the mass, so the acceleration, 1.8 times 10 to the 2, and we get 4.0 kilograms. Now this question is a little more complicated, so it's important to write out everything we know. So first of all, we're told that mass is equal to 21 grams, which is 0.021 kilograms. We know VI is 18 centimeters per second, which is 0.18 meters per second. We know VF is 28 centimeters per second, which is 0.28 meters per second, and we know time. Time equals 0.10 seconds. Okay? We do not know acceleration, so to go to our formula, F equals ma, we are looking for F. That's the question. We know the mass, 0.021, but we don't know the acceleration. So let's find that out first. So let's do that here. So we need to use one of our 5 equations. So we're going to use A equals Vf minus Vi over T, which is 0.28 minus 0.18 divided by 0.10, which equals to 1 meters per second squared. So we're going to plug that number in here. We're going to plug 1.0 meters per second. We're going to do our math, very easy math, and we're going to get 0.021 newtons. Now we're only looking for the magnitude, so we don't need the direction in this case. So our final answer is 0.021 newtons. Okay, this question is more complicated, so you need to write everything up. That's the first thing you need to do. So let's divide it into what we know. So the train and the cars. Now the train has a mass, 48.3 tons, and we are told that 1 ton equals to 1.0 times 10 to the 3 kilograms. Let's move that for a second. Put that over here. So that means the mass of the train is going to be 48,300 kilograms. We know the force is 22.4 kilonewtons. We know that 1 kilonewton equals to 1,000 newtons. Therefore, the force is 22,400 newtons forward. The force of friction, we know, is 10.1 kilonewtons, and like we did before, that's going to equal to 10,100 newtons. And that's going to work backwards, okay? Always in opposition to motion. Now the cars, we know the mass of the cars is 2 times the train. Therefore, the mass of the cars is 96,600 kilograms. And let's assign a direction. We'll say this is forward, and it's also positive. Now the next thing we need to do, so that's number 1. We write out what we have. Number 1. I'll make that clear. There we go. Number 2, we need to find some of the F's. Okay, some of the F's is going to be the force of the train, 22,400, minus the force of friction, 10,100, and that is 12,300 newtons forward. Now number 3, third thing we need to do, is we need to find total mass of the system. Now the system is going to be composed of the train and the cars. Okay? So we'll say train plus cars. So we'd say the mass of the system is 48,300 plus 96,600, which is 144,900 kilograms, because that's what needs to be accelerated. Right? We need to accelerate the entire system. So number 4 is we're going to plug that all into our equations. We're going to say sum of the F's is going to equal to sum of the M's times the acceleration of the system. We're solving for the acceleration of the system, therefore sum of the F's divided by sum of the M's, which is 12,300 divided by 144,900, which equals to 0.085. So we write our therefore statement. So we say therefore acceleration of the system equals to 8.5 times 10 to the negative 2 meters per second squared forward. In this question we have the sum of the forces is our question. Mass of our object is 1.31 times 10 to the 3 kilograms. Initial velocity is 0. Final velocity is 28.6 meters per second forward. And time is 5.60 seconds. So that's the first thing we do. We need to write out everything we have. Second thing, we need to solve for acceleration. Acceleration equals Vf minus Vi over T, which is 28.6 minus 0 over 5.6, which is equal to 5.107 meters per second squared forward. We keep 4 sig digs because we need 3 in our answer, so we keep 1 extra to make sure we don't round too early. Step 3, we're going to find the sum of the forces. That's going to equal to mass times acceleration. The mass we have is 1.31 times 10 to the 3 kilograms. The acceleration is 5.107 meters per second squared forward. And our answer is 6,690.17 newtons forward. We need to round. We have 3 sig digs in our answer, so our final answer is 6.69 times 10 to the 3 newtons forward.